Hello learner, welcome to the learning of computer networks and security. Let's continue with the module 3 concepts. Let's learn here the forwarding table concept. Let's continue with the discussion of our BGP, Border Gateway Protocol. We'll see how the entries are done into the forwarding table of router. Okay, let's see this with an example. How an entry gets into forwarding table? Just look at the forwarding table over here. You can just have an autonomous system. You can just see an autonomous system here, which is blue in color, and then we have a packet which has to be sent to this router into this autonomous system. So whenever a packet enters into the autonomous system, here you can see first it has to reach to the gateway router. So this gateway router is a border router. You can say this border router is the one where BGP is running. BGP protocol is running, border gateway protocol, and through this border only your packet has to enter. But there should be some information provided by this border router. So what is that information? You call it as the forwarding table or the router table maintained at this border router. So what is that forwarding table? What information it will have? So the two information, one is the prefix information, the other one is the output port. So you can just see here the border router has three interfaces, three outgoing ports. One is connecting to some router, the outgoing port 2 is connecting to some other router, the output port 3 is connecting to some other set of router, some other router, right? So here this destination packet can move through any one of these routes. It can take up any of this interface, but it has to be redirected out of 3 into only one output port. It should reach only to its destination to which it is supposed to reach, right? So how will it find out? So it is this border router who will help here for the packet to reach to its destination. So definitely this border router will check its forwarding table and it will see the destination address. So the destination address is in the form of a prefix, and you can see some prefixes specified here. The first one is 138.16.64/22, second one is 124.12/16, and then 212./8. So these are the three different subnet addresses, prefix you can say, and you can see the different outgoing port over here. So if the destination address is having the prefix of this first type, then it must go through the outgoing port 3, and through this outgoing port 3 it will reach the destination. Okay, and then you can see the next one, that is 124.12. If it has to reach to this destination, it must go through 2, output port 2, and finally if it is if it has to be sent to this 212 prefix, it should move through the outgoing port 4. So this is how our forwarding table will help the packet to reach its destination. Okay. You can just see here how the entry gets into forwarding table. You have by now you must be knowing how the router prepares its routing table. So first actually the router should be aware about all the prefixes of the subnets that is attached into the autonomous system. So there if you can recall the autonomous system something like this. And within the autonomous system, maybe if you have around 5 routers, say I'm speaking about now the border router. So the border router here should be aware about all the other 4 routers here connected to it, and all the subnets that is attached to these 4 routers, its prefix, its addresses also should be known to this border router. So through the intra-AS routing protocol, it can be aware about the prefix there. So prefix can be entered into its now forwarding table or the routing table. So that forwarding table is maintained now by this border router. Next, also along with the prefix, it should determine the output port. See, some of the subnets will be reaching through the output port C1. Some of the prefixes may be reaching through the output port 2. Next, some may be through output port 3. So this output port also should be maintained in its forwarding table. So here border router should prepare its forwarding table first, and then only it can help the incoming packet to reach its destination. Now you can see the next one, that is the router enters the prefix port in forwarding table. So this is finally what it does, right? We can just see now how the router becomes aware of prefix. Okay. Uh, yes, this is just an example. Now you can see autonomous systems, 3, autonomous system 1, and finally autonomous system 2. There are 3 autonomous systems here. And now suppose if any one subnet here which is connected to any of the routers within AS3, any one subnet maybe wants to send a message or any packet to AS1. Okay, so in that case, how is it forwarding? It is only through this border router 3A, which is belonging to AS3. It sends the BGP messages. So we call it as a BGP message. Why? Because it's the border gateway protocol which is running at the border routers. So the BGP messages first should be exchanged between the border routers. In order to send any packets or receive any packets, first BGP messages should be exchanged, right? And next, now you can see the message. Once it is exchanged, you will get to know the all reachable subnets here within AS1. So that all reachable subnet will be forwarded by the border router 1C. So all reachable subnets here in AS1 is maintained at forwarding table of 1C. So that information, that forwarding table information will be shared with the border router 3A. So now 3A, that's how we'll come to know whether the packet should be sent to this AS1 or not. So once it looks at the forwarding table, 3A, border router 3A then can send the packet to the border router 1C. So that's how 1C can forward that destination or a packet to the destination if it is belonging to AS1. So we can just see now what information is maintained within this BGP message. So the BGP message, it contains the route information. So what is this route information? So the route information contains 2 parts. One is the prefix. Prefix is nothing but the address of the subnet, destination subnet. Suppose if the destination subnet is attached to 1D, its address, its prefix will be definitely maintained at forwarding table of 1C, right? So that prefix. And then next, one more information maintained is in the route is attributes. So what are the 2 attributes we have? BGP attribute. One is AS path and one more is next hop. So what is AS path now? Suppose if the destination subnet is attached to 1D, which is belong to AS1, then in that case the AS path would be AS3. That means that is from the source AS3 you are reaching the final destination AS1. So this you call it as AS path. Next, also we have one more attribute along with that, that is next hop. So what is next hop? That is with respect to the router. The next hop is nothing but the router. Suppose here the source is somewhere attached to 3C, the next hop to that is 3A, or else if you are sending the packet from 3A itself, so that packet, for the packet, the next hop would be 1C. The next hop router would be 1C. Okay, so that is the next hop router you maintain within the BGP message. So in this case, it is 1C is the next hop. Okay. So you can just see few examples. Prefix. So for prefix, if this is example, this is the destination subnet address or prefix of that. And next, the AS path. The attribute is AS path. So AS3 to AS1. So this should be AS3 to AS1. Okay. So this part's not there. Next hop. So next hop you can see. So what is this next hop? You can just see one IP address, right? So what is this IP address? In this case, this should be the IP address of 1C. So what is the IP address of that 1C? So you assume that it is 201.44.13.125. So this should be the address or IP address of the next hop router. Okay. Let's see the router that may receive multiple routes. So we'll see what happens when the when a router or a border router 1C, when it receives multiple routes. So what is the meaning of multiple routes? See, for example, I have a prefix, okay, and that prefix is something like 132.16.18 dot something, okay. So for that particular prefix at 1C, if it receives multiple routes, so it is something like if I have a subnet, which is attached to 1D, and here for that particular subnet to reach there from 1C, there are multiple routes. You can take this route, or you can take this route, or you can take a direct route. So among these routes, which route you would prefer to reach 1D, or in order to reach this subnet, you may take up actually the shortest path. So that is the concept, right? So definitely for a particular subnet, there might be multiple routes. So here that is the meaning. So what if a router receives multiple routes for the same prefix, what has to be done? So in that case, you can just see here, in that case you can router 1C has to select only one route. As I already said, BGP has to select the best route. So what is the meaning of best route? So for a prefix, suppose a router if a router gets more than one routes for a particular prefix, in that case, the router has to choose the best route. So based on what the router chooses the best route, it is based on the shortest path. So example is, if I have a AS path for a prefix 138.116.64/22, for this particular prefix, if there are two routes, one is AS2 to AS1 and one more is AS3 to AS1 and then to AS2. So among these two AS path, which is the shortest? Definitely it is the first path that is shortest, AS2 to AS1, in order to reach this particular prefix. So the best route is based on the shortest path. So if suppose the two routes, multiple routes, there are two routes to reach this prefix 138.16.64. Among these two routes, these two are different routes, but in case if it is having the same AS path, something like say AS2 to AS1, to reach this is one particular path. If there is one more path, something like AS3 to AS1, in order to reach the same prefix, in that case both the path length may be same. So how to choose the best route? So in that case there will be a tie, right? So how to break a tie? So breaking the tie, we will just see in the next concept, that is hot potato routing. We can just see here the best intra route to BGP. So what is this best intra route in the sense? So first of all, a border router has to choose the best path. So as I already said in my example, if there is a subnet or if the destination is connected to 1D, in that case 1C can reach 1D along multiple paths. So 1C can reach 1D directly, or 1C can reach 1D via 1A, or 1C can reach 1D via 1B. So there are multiple paths. So among these, there is one shortest path or the best route what 1C has to select, and that he can select using OSPF, right? So OSPF is an intra-routing protocol using which a shortest path can be calculated inside the autonomous system, or intra-routing can be done. So who is doing this, calculating that? It is 1C. It is the router 1C, which is a border protocol, border gateway router, or you can also call it as a border router which implements BGP. So intra-routing must be calculated using OSPF. So you can see the also if there is as I already said in the previous case, we had multiple AS paths. Suppose if I have multiple AS path to reach the uh, same destination, so if both the paths that we have same length, in that case how to break the tie? That was a problem, right? So solution is we can choose the closest next hop router. So what is the meaning of closest next hop router? Closest next hop router is, suppose AS2 to AS1 is a path in order to reach the destination. So here, in order to reach from AS2 to AS1, the next hop is which one? 1B. Or else if I have to reach from AS3 to AS1, so the next hop router, closest next hop router will be 1C. So the next hop is that the closest router in order to reach the destination. So that is the next hop router, and the next hop router, based on that you can select the best path to reach the destination, and in that case you can also break the tie. So here there is an example. So next hop is given in the form of an IP address. So 111.99.86.55 is the IP address of 2A, router 2A, and AS1 to AS2 is a path. AS1 AS2 is a path. In this case, if this is the path, how to choose the next hop router? So the next hop router is this 2A. In order to reach this AS2, the first closest hop is 2A, and the IP address of that is given over here. So as I already said, OSPF is used to choose the shortest path from 1C to reach this 2A. So from 1C to 1B, there are again multiple paths. Via 1A it can reach 1B, or via 1D it can reach 1B, or 1C to 1B directly it can reach. So this shortest path calculation within the autonomous system is done using OSPF, and then using the closest next hop. Closest next hop is via 2A. This is how it will reach the final destination. So AS path is AS1 to AS2. Next, how the router identifies port for route. So what is the meaning of port here? See, for example, I can have here 1C as one of the router, and in order to reach the destination here, there are multiple routes what it can take. Suppose if a packet has to be sent from 1C or AS1 to AS2, AS1 to AS2, it has to send the packet. So in that case, 1C has, suppose if it has a packet, 1C should redirect that packet to AS2. But how he can redirect? First it has to find the path to 1B, that is the shortest path it has to find to 1B, and in order to find the shortest path to 1B, actually it should know the outgoing port there, right? So what is the outgoing port? Suppose here 1C to 1B, it can take via output port 3, it can take the path via output port 2, or it can also take the path of output port 4. So there are multiple output ports, 2, 3, 4. Out of that it can choose any one, right? So definitely once is going to choose the output port 4 in order to reach 1B, and from there onwards it will just choose the next hop as 2A in order to reach the final destination autonomous system AS2. So the output port is chosen over here along the shortest path in order to reach the destination. We have hot potato routing here. So hot potato routing, it is something like, suppose if there are two or more best routes. So what is the meaning of two or more best inter routes? For example, I have a router 1C here, and router 1C actually can reach this 1D directly, and 1C also can reach 1D via 1A there, right? So suppose out of these two paths, the cost to reach this from 1C to 1D and the cost to reach from 1C to 1D via 1A, if both the costs are same, or if both the paths are shortest path, in that case what the hot potato routing does, it should choose the closest next hop. So closest next hop means what? So 1C can reach 1D directly, so this would be the closest next hop, or 1C via 1A and then 1D, this would be little far, that is it has to pass through one more router, right? So the closest next hop is this 1D. Or else if I have to give one more example, so 1C can from 1C the packet, if it has to send to 2A, or from AS1 to AS2 if the packet has to be redirected, so 1C will first send the packet to 1B, and then from 1B it will reach 2A, right? So in that case the what is happening there, the route whatever it has to choose, 1C to 1B, it will take the shortest path to reach 1B. The shortest path is calculated using OSPF, and then there onwards it will choose the closest next hop. So closest next hop here is 2A, right? So in that case it will finally redirect the packets. So this closest next hop thing will be selected if there are more than one best inter routes. Okay. So we can see here from 1C, that is choose it has to redirect the packet. So here 1C can redirect the packet actually to AS3, or else it can also redirect the packet to next AS2, right? So okay, fine. So this is a different example where suppose a packet has to send to the destination. Suppose if the destination is there in AS3, or it also has the destination in AS2. So in that case, 1C, the packet can be transferred from 1C to 3A, or the packet also can be redirected from 1C to 2A. So in that case, 1C, for 1C, which is the closest hop, the closest next hop is 3A. For 1C, in order to reach the 2A, it has to move via this particular intermediate router, right? So this 2A is not the closest next hop. So for 1C, 3A is the closest next hop, right? So in that case, 1C would choose 3A as the closest next hop, and then onwards it will redirect the packet to 3A, and from there it will reach the destination. So this is the example where if a 1C packet has to choose the best route, and if both the routes are shortest path, giving the same path, that is same shortest path cost. So 1C to 3A if the cost is same, and 1C to 2A also if the cost is same, in that case both are chosen as the shortest path. So which path should be chosen? It is the closest next hop should be chosen. For 1C, 3A is the closest next hop rather than 2A. So this is what is called hot potato routing. Next we have how does entry get in forwarding table. Okay, so here this is till now we have seen how the entry we can make into forwarding table. So all these we have seen, just a summary of that. So here first router should be aware, that is the border router should be aware about the prefix. So prefix means it is the destination, where exactly this destination is connected to. So about that the router should be knowing, and then that can be known via intra routing protocol. So intra routing is done, and all the information about the prefix is collected, and that is entered into the forwarding table. Along with that also it should know about the output port. So you can see the output port for the prefix also should be known, like 1 2 3 4, there are multiple paths to reach the prefix, right? So that output port also is entered along with the prefix into forwarding table at the router. And then one more thing is the advertisement is made. So route advertisements are made from one router to the other. So border router can send this information to the other border routers belonging to other autonomous system, or this information of forwarding table can also be shared among all the other routers inside the autonomous system. That can also be done. So you can just see BGP route selection is done to find the best inter-AS route. That is you can a border router can choose any closest next hop in order to reach the destination. So once the forwarding table is ready, it can redirect the package to the other AS by choosing the best path, shortest path. So in OSPF is a protocol used to choose the best path inside the autonomous system. Within the autonomous system, shortest path is calculated using OSPF, and then router identifies router port for that best route. So router port, that is the outgoing port, also is chosen for the best route. So once that best route is calculated, that prefix port entry, that is the closest path whatever it has calculated, that can be made an entered into the forwarding table. Okay. So we have the next important thing, that is how the routing can be done from one autonomous system to the other autonomous system. We call it as inter-autonomous system routing. So there is some policy which has to be followed whenever you send the packets across the autonomous system. So you can just see here there are multiple autonomous systems starting from A, B, C, and then we can see here W, X and Y. So all these are autonomous systems. Total there are 6 autonomous systems. Out of that, let's call this ABC as backbone provider networks, provider network, whereas W, X and Y are the customers of these provider networks. So who are the customers for autonomous system B or provider B? So X is a customer for the provider B. Similarly, C is also a provider for which we have 2 customers. One is X and one more is Y. You can see there is a connected link between C and X and C and Y. Similarly, B has only the directly connected link to X. Whereas A provider network has also one customer, and that customer is W. And you can see all A, B, C are the providers which are interconnected with each other. Okay. So here, what is the policy that has to be maintained in order to send the packets across the autonomous system? Or let's take an example over here. You can just see X is a network, X is an autonomous system, or X is a customer of 2 providers. One is the provider B and one more is the provider C. So X is a customer of 2 providers, right? So Y as well as W are the 2 customers which are providers of only, which are customers of only a single provider. So here in this case, what is a policy? We'll just see. Suppose here X wants to send a packet. Okay, X wants to send a packet to B. Okay, to B. So in that case, or else let me take the example in this way. Suppose here W is a customer, and W is actually reachable directly to the provider A, right? So A can reach to the autonomous system W directly, and this path whatever A has to reach W, this path as per the BGP, as per border gateway protocol, this path should be flooded to the, or that information should be shared with the other providers or the other autonomous system. So about the reachability information should be circulated, or it should be broadcasted to the other autonomous systems as well. So W is directly reachable to A. So this information is actually passed on to the neighbors of A. What are the neighbors of A? B, as well as it is also sent to, the information is also sent to C. That is how our provider B and C, or our autonomous system B and C, will come to know that there is a path to reach this autonomous system W via A. Correct. So this information is now once it is known to B, so what B will be doing now anymore? So it is something like, suppose if B wants to send a packet, to W, B wants to send a packet to W, so it will definitely it will send the packet first to A. Why? Because through A it came to know that W is reachable to A directly. So B will first redirect the packet to A, and then that's how A will reach finally to W directly. So this is actually the path known, or this is the path chosen to reach W. Suppose here C also wants to send a packet. In that case, what C will do? Anyways, that information is also shared with C. So what is that? Reachability information. C also, if it has to send the packet to W, first it will reach A and then it will reach W. Now here, the question is whether B has 2 neighbors. Definitely yes. B has one of the neighbor, that is A providers. I'm speaking about provider neighbors. So B has one as A provider and one more is C provider as its neighbors. So B, whether it has to share the information about its reachability to W. So this information, reachability information, B can reach W via A. Whether this route information, whether it should be advertised to the provider C. The provider C is a neighbor of B, right? So whether B should share that information of reachability to C. So what if B shares the path? What is that path? The path is B, A, W. Suppose this particular path is advertised to the provider C. What are the chances, or what is that advantage what C may take on this? So our provider C can now act smart once it gets this information about PAW. Suppose C wants to send any packet to W, what C will do? Instead of sending it to A, first it will redirect the packet to B, and via B it will reach A and then it will reach W. Why is this C doing? because C is a provider which do not want to take any burden. What C can do, simply it will pass on the packet to B. Now B has to take the headache of routing the packets from B to A and thereon from A to W. So this is actually the drawback of advertising the route information by the provider. So here there is one more example. See here, X is a customer of both B and C, right? So X knows that it can reach B directly as well as X can reach C directly. But here, what if the information is shared? So what is that routing information shared? Suppose here Y is a customer which is directly attached to C. Suppose if Y has to send a packet to X or something, Y can take a route of Y to C and then it can reach from there to X, right? So this is actually the direct path from Y to X via C. This is fine, totally fine. But if X wants to send a packet, say to W. So in that case, how X will say? So X can actually send the packet to B and then from B to A, then from A to W, right? So here, whether this information, reachability information, suppose if it is shared, suppose if C comes to know that X is also reachable to B, in that case, what C can do, there all the packets, incoming packets from X can be redirected to B. So that means what, C is simply putting the headache of passing the packets from C to W. Actually C had to send to W, but what simply C is doing, it will simply redirect the packet to B. So that is something like, let B provider take the headache of passing the packet to W. So B then will redirect to A and then it will reach W, right? So C is simply passing on the burden to B. Similarly, B also can do that. Suppose if B comes to know that X is reachable, C is also reachable to W. So anymore, whenever X sends the packets to B, B can redirect the packet to C. So it is something like B's headache is passed on to C. C then can redirect the packets all the way to W. So this is actually the chances happening in routing. So there is a policy which has to be followed, a routing policy which has to be followed in BGP whenever the packets are transferred across the autonomous system. So in that case, what is the policy it has to follow? What is the solution to avoid all these problems? It is B should not advertise the information. So what is that? It's reachability information, B to W. That reachability information should not be advertised to C. This advertisement should not be made. Similarly, C's reachability information to W, that should not be advertised to B. So this advertisement should not be made among the neighbors. So if it doesn't advertise, in that case there won't be any problem at all. So we can have here the next routing policy. The same example is taken here, whatever the example I said, A to W. So A to W information, it is advertised to B. That's how B will come to know that W is reachable. Similarly, this BAW path information is shared to X. So X can reach W. That's how via B and A. Suppose this advertisement is also shared with C. C can take an advantage there. So instead of X, whenever it sends a packet to C, C will simply redirect the packet to B. So this reachability information, this BAW path information should not be shared with C. So this is the routing policy. Okay. So finally, if we are summarizing, there are two different types of routing. One is intra-routing and one more is inter-AS routing. So what is the policy? Actually, in inter-AS autonomous system, that is across the autonomous system, the policy should be maintained. So here there are multiple admins. Why? Because one AS, for each AS there will be a particular admin, right? So there will be like multiple admins who has to control this traffic across the autonomous system. Whereas when it comes to intra-AS, so need not be any policy there. So why? Because it is a single admin within the autonomous system. So no policy decision is required as such. Only it is in inter-AS, across autonomous system, policy decision has to be made. So scalability is also there. So if suppose hierarchical routing, so because of this hierarchical routing, the table size what we have, routing table size or forwarding table size, it will be saved. So therein there will be traffic which will be reduced there. Okay, so finally intra-AS can shortest path calculation can increase the performance. Similarly, inter-AS has a certain policy because of which the performance can be increased.